Thank you so much for being here. First of all, I was in Iceland last week, and there they had a saying. I learned that an ancient saying that if it's foggy, you cannot see that far. So I hope this presentation is not going to be so foggy, so you can see what the meaning is behind it. The meaning is to look at how we can see the symbiosis between how we handle data and how we handle the infrastructure in data centers. So first of all, my name is Henrik Borling. I come from the Huawei, from the Nordic region. So I make that mistake when I traveled here yesterday. I was dressed for winter clothing. And this is for a Danish perspective, very bad. This is a hot summer in Denmark, I can tell you. So this was misdressing in a wrong way. So, but I work within business development, and I'm going to take you to a short journey within what we see of perspectives within sustainability, within energy management. First of all, I'm not going to tire you with a lot of numbers from Huawei. I just want to say that we are almost 200,000 employees in Huawei, but what I want to point out here is that more than 107,000 of them works within R&D. That means that more than 54% of all employees within Huawei works within R&D. So this is, and I think they work, all of them. They're not only employed. When we look into the data center part, we know that we are in a transition. We have a lot of things running for data centers, and data centers is here to stay. For instance, we know this terminologies like smart cities. This is how we have the digitalizations of municipalities. We know about Industry 4.0. This is not only for the industry, that is actually how we see the digital twin from the IT solutions. Another part is where we say IT goes OT. This is also when we talk about edge computing, where we need to act fast, like in processes for IT. And this is what we want to look into. There's not only bad things of the increasing of the IT. For instance, if you have teenage children, I can tell you raising children has been so much easier when you have a conflict at your home. Normally, in old days, you could have your children grounded for days and they were still arguing against you. Today, try to take your phone from your teenage daughter. For 1 hour, she will tell you, oh, my social life is in ruins, give it back, sorry. So something is happening. And when we look at what kind of data is changing for this, we see that the most important part for data is the AI and HPC. And I don't know if you know what is 4,600 EFLOPS. And do you know how much energy that is? Oh, I'm so happy, then I don't have to explain it. But that is something, you can come to our booth afterwards, and I think I have some figures about that. But when we look into how AI is used, in Huawei we have a homepage called Check for All. Check for All is where we have kind of projects we are supporting or running worldwide. For instance, in the rainforest in South America, we have a project where we monitor the extinct or threatened monkey there called the spider monkey from extinction. So there we can monitor, that is by listening to what is happening, and AI is listening. It is so precise, so it actually can identify the individuals of the spider monkeys. But the reasons is to see when there's poachers or illegal foresters in the area. The same is with the whales. This is of the west coast of Ireland. For whales, noise is pollution. So the whales have begun to not come into the coast of Ireland because of noise pollution. And that is because of the shipping of ferries there. There also they are going to monitor what is in the dangerous levels for the whales not to come there, and how can we adapt it to the shipping there. There's also a lake in Austria where the birds are not coming anymore, or they are stopped showing up there. And that is because the decreasing amount of insects in that lake. So this is also a research put into we can see we can use AI solutions. The last point is to communication for rural areas in Africa, to make communications for them. I want to show them a local project we have, and when I say local, it's in the Nordics, it's in Norway. So for me, local is Nordic, just so you know it. This is a humpback salmon. Humpback salmon is an invasive species in the Norwegian lakes, and they are pushing back or threatening actually the original Atlantic salmon. And they also are producing a lot of pollution in these lakes because they are expanding very huge, and they're breeding more fast than the normal Atlantic salmon. So they are breaking the ecological system there. So the AI solution is by running a monitor system first of all, to monitor the salmons there. So this AI making very fast film sequences of it, and from these sequences they make identifications of the salmons or anything passing through there. That could be divers or anything. But they want to make the perfect identification of these two species, like the Atlantic salmon and the humpback salmon. And the humpback salmon is also called the pink salmon. What they learned from this is we are going to process a lot of data locally. So when we look into how data is and data center parts of it, it is locally run data. So here we identify the species or everything that passes. And the meaning by this is actually to get rid of this humpback salmon. This is to push them into a lake, and we can gather them from there. This is the way to go for it. When we look into how we count it, and from the camera sequences, this is producing a lot of data. This is why we say data is increasing also from the high performance computing, but also from AI. And here you can see we are calculating no fish, small fish, pink salmon, this is the humpback salmon, and Atlantic salmon, and other also. This is gathered together. Now this is done locally, but when we look at it from a data center perspective, then we actually can see how can we run jobs versus what we get into it. First of all, we have the AI running locally to identify the salmons and to take the pictures. Then we have an overall AI running. This overall AI is running to take all these pictures, and from these pictures we actually found out we can identify the species or the individual salmon. So we can say if one salmon have passed for some months ago, it comes back, we can count it. Now we can count them identically. Another part is we can also monitor how fast they are swimming. And one of the things we found out about this was actually that salmon swimming not that fast, they could be having this lice disease. So this is a way to monitor and handle the data. Why I have shown the picture about energy versus job acceptance. This is to show that we actually don't need to run all the jobs at the same time. So here we can have an alignment between the infrastructure of the data center, but also how we perform the jobs. Why do we make a job so it's ready at 6 o'clock in the afternoon when no one is going to look at it? Why not wait with that job to make it in the nighttime when there's more energy and it's cheaper, so we can run it so it's ready in the morning instead? This is how we can push jobs to be made when we have the energy for it. This pushed me to the next part. This is the data center setup. And I'm so glad that I've heard some other people today talking about the Open Compute project, because I think this is something we need to promote to have a sustainable energy management. First of all, we look at the how we are going to make the supply of the energy to the data centers. We look into what we call directly renewable energies. That was what we heard, like solar panels directly, or energy like wind energy. And also how we are supplying with the grid and how we are going to stabilize the grid. And I just have one comment to how we stabilize the grid. The grid is not that stable anymore because of renewable energies. In Denmark, we had one of the hyperscale data centers coming. And they asked us, and that was for some years ago, when we had actually a very, very stable grid. And the hyperscalers asked our government, how stable is the grid in this area? Then the representative said, it's 100%. He said, no, he said, since 1958, we have no breakout on the mid-voltage grid, so it's 100%. No, they said, can we trust it? We wanted to have a diagram of it. Okay, can you send it? Oh, of course, he said. Then he made this. And this is, of course, something. But when we look at how we are going to look into energy management in total, we are looking into how are we going to make the stability of the grid. For instance, we have what we call the Nordic Immediate Challenge. This is because we have a huge part of our energy production is from renewable sources. That means that we cannot control the production 100%, but the consumption is what it is. So we have this instability part of it. And this is why we promote FFR solutions. And also another part is FFR stands for Fast Frequency Reserve. I think we have heard some people today talk about it from UPS side of it. We want to increase and say it's not only from the UPS part of it, it also to have energy storage systems in large scale connected to data centers. I will come a little bit into that later in the speech here. Another part is how are we going to make the cooling? This is why I'm so glad people have mentioned the Open Compute project, because here we see different kinds of cooling solutions, like instance chip cooling, cool plate cooling, and immersion cooling. This is solutions made for HPC computing. And one of the best part is we are running at so high temperatures there that we can make it for heat recovery. I don't know, I don't think you need that for district heating in Greece, and not when I look at the temperature you have now. But I can tell you in the Nordics, we can use it. And this is also why we need to change the reputations of data centers. Now they are the sinner because they are using a huge amount of energy. Why not say that data centers, they actually are a part to stabilize our grid so we can have more renewable energies to the grid, but also they are energy transistors, like they are transforming electricity to heat. This will bring a new situation, because when your teenage children at home are playing PlayStations and they after 3 hours said, we are tired, we are going to bed. You said, no, you need to play at least 1 hour more because we need the heating. So we are in a transition phase. How can we move from one part to another? And how is data centers going to influence this? And when we look at these standards, I think you all know these standards. They are the most common standards within data centers. For instance, ANSI BIGSI 002, they have the same as Uptime and TIA 942 and EN 5600. They have 4 and 5 levels of making a data center, how resilient is the data center in it. I will focus on the EN 5600 because this standard is the only that is European. I think we need to see this from a European perspective. Also because I work in this committee, so it's easy for me to talk about it. And then you can see it's the same framework. This framework is actually the same as we try to look into. It is to how are we going to use the renewable energies, both directly and indirectly. And the next part is how are we using other resources like water. I just also heard one of the other speeches that we don't need only to look at the PUE, but look at all the ways we can calculate for data centers parts. And for instance, when we talk about water is used, for instance, for adiabatic cooling, or how you can spray your condensers to increase the amount you can use it for free cooling. But then you need to monitor and measure how much water you're using. And another part is energy storage. Energy storage is a way you can get your usage of the data center and you can align it to when you have renewable energies available. You can use it from the energy storage, not only from the UPS, but use it as an energy storage part of it. And lastly is energy reuse. And I don't think it's the same we are talking about. I talk about heating and how we can use it again. And one of the part is when we are using these cooling solutions, we really have some heating we can bring into to it. For instance, when you are using chip cooling or cool plate cooling or immersive cooling, you are running at very, very high temperatures. You're running actually at 45 to 55 degrees. And that is another problem, because when you are, in normal terms, you talk about cold aisle or hot aisle, and you talk about the cold side of the data center and the hot side of the data center. Here we are talking about the hot side of the data center and the hotter side of the data center. So we are actually desperately looking for Finnish technicians, because they're used to be in saunas, so they can work in data centers for the future. So when we look into ISO standards, we saw people also promoting them for a new measurement, and there is this ISO 30134. Really is something we are going to use. When I hear people talking about and say we have the greenest data center ever, I always said yes, according to which matrix. Use them. There is some very good benchmarking points here. But two other parts that's also part of this standard is actually how are we using the servers or the active equipment. Active equipment in a data center stands for more than 70% of the energy consumptions. Why not align it with the infrastructure and how you use it? So this is also points where we can look into how we do it. For instance, when servers are put into production or commission, always they are running at the fastest speeds. I don't know which car you have or if you have a car, but I think you always know there's an economy mode, there's a comfort mode. Some cars also have a sports mode. All these servers are running on Sport Plus, I can tell you, because when they are set into commission, they start them at the best performance ever, because they have to show how fast are they and how can they make the desired calculations. But how are they running afterwards? This is, are they running all this data that is supposed to do in the data center or not? So this is where we really need to have some alignment. How are we using the data and what kind of energy can we use there? And I can tell you, from a server that's running on very low load and a server that's running on very high load, there's 70% in difference. So something can be done there. For instance, in your home, is your oven on 400 degrees all the time? Because you occasionally are going to bake a cake or make a roast. This is the exact same thing we are doing with servers. They're running, and we don't look into how can we make it from an energy perspective to run the servers, to help the infrastructure run it. And then we are looking into what is happening in Europe. I think we know all of this. There was, for some years ago, from 2014 to 2019, what we call LSA for regions. It was an EU project, how to measure the components for life cycles assessments. And the European Green Deal, I think we also know that part. That is to be CO2 neutral in 2050. Fit for 55 is an amendment to it, because we want to have our CO2 or GHG reduced by 55% from 1990 figures. So this is what we have there. I think you in the next couple of years you will hear a new term called resilience to our temperature risings. So this is some of the things we really need to focus on. Something is happening. I think you know that. And when we look upon the independent systems and the grid we have here, I try to make that from a Greek perspective. But I also have done it from Iceland. When you see here that Iceland, they are 100% renewable and 100% low carbon, how can there still be a carbon density? Do you know that? This is because when we talk about low carbon and renewable, we are talking about scope 1 and scope 2. We need also to take into consideration scope 3 emissions, and this is the dark horse in the race for sustainability. When we then look at the Greek, this is at one certain point, and you can see from the date, that is from Sunday. Here we have a very high amount of renewable energy in the Greek grid. You actually have so much, so you are exporting it. So you are exporting 108 megawatts to Bulgaria. But when we look at the Greek carbon intensity for a year, it looks a little bit otherwise. Then you are at 340 grams. So how can we use these data to control data centers? Because the data is available. We can go into and see when will there be green energy available or renewable energy available. So looking into this, from this company, this is called electricitymap.org. It's not a Huawei company, but it's a company that you can buy the AI from them to rely on how you can control data from them. They have collected the data since 2018, and they update it all the time. And that means that they actually can forecast up to 24 hours ahead of this when there will be renewable energy available. With this knowledge, you actually can go in and say, when I'm going to use my energy storage systems and when not to use it. And I can tell you, there's a very good relationships between when there's renewable energy available and the prices for energy. So of course, this is also to be cost effective when you do it like this. What's the next step? The next step is actually to have this as, first of all, to be carbon neutral. When I say carbon neutral, it is only from scope 1 and scope 2 perspective. And then we need to look at how can we reduce it. This is also for the commissioning part. So to be total carbon free means you have to control it, and you need to be there and have this energy consumption under control. That means when you look into how you can make it 100% free and 24/7, you need to collect the data. And next part is that you need to take this data and you go to buy that energy when you have it. And with this knowledge, you can buy the energy in front of when you use it by contracting. And this contracting is actually done by blockchain. I don't know how it is in Greek, but we are having a discussions about how is it legal to buy green energy or renewable energy in bundles from energy companies. It is what we call greenwashing. We need to be 100% sure when we buy renewable energy from the grid, it is renewable energy and where it's from. Then blockchain could be a solution to be there. And that means this, I'm not going to have a speech about blockchain, but anyway, there is different kinds of blockchains. I think you know the proof of work kind, that is what the Bitcoin is based on. There's a proof of stake, that is like Ethereum is based on. And then there's two others, proof of burn and proof of authority. This is based on proof of authority because here it is digital ledger in the pure form, buying the energy in contracting in front of the usage. All this is tied together with an overall control management system. And that is our own AI solution. So
Huawei uses cloud and AI technologies to collect information at over 700 points for monitoring the running status of the cooling system in real time. Moreover, DNN is used to train and deliver PUE models to the inference platform. The PUE adjustment model is optimized to the current temperature and IT load rate. When variations in outdoor temperature exceed 2 degrees Celsius or IT load rate exceed 5%, the inference platform starts the next round of optimization and delivers the optimal control policy within 5 minutes. The control parameters are then adjusted at the same time, and the cooling system is balanced in about 1 hour. Thanks to AI, the PUE can be optimized by 5% to 15% annually, greatly enhancing energy savings.
this means to look into how AI is a solution we can provide for data centers, is to look into how is a usage for it. When, for instance, a data center is put into commission, I don't know if you know how it is, but when it's put into commission, you are making, for instance, a SAT test, a special acceptance test for how the data centers work. And that is normally with the maximum heat load, and you control that you have the right redundancy for the data center, and you can manage and you can cool or distribute this heat load you have there. This is normally. And then you have when you have it commissioned and you have it delivered to the customer, then it runs. How many data centers do you think is running on 100% of what it was tested for? I can tell you, if you know one, please tell me, because I haven't found one. Because we always start at an beginning load, initial load, and that is perhaps 30% of the maximum load, and then it increases from there. But how do you control that all the equipment you have to distribute the power, to make the cooling, that it is running in accordance to that load you have there? This is where AI can help you. Not only by looking at, but it is gathering all the data, and then also have ability to control even set points in the data centers. Meaning that it can test its own resilience, but it can also adjust to the heat load or the actually IT load you have in the data centers. So we have this, what we call the 6 levels for it. Meaning from the first level, that is, for instance, like you are making it as a almost old engine room. You are going in turns there and you are noting everything's happening there. Until what we call fully autonomous DC. That is where we have no people working there, and it's fully self-healing and autonomous is running. At this stage, we think we are between level 2 and level 3 because AI is coming to the data centers. But what we want to look into furthermore in this part of it is also how is it used for optimization part, but also for the energy part. And this is where I really think we need to focus on the active equipment again, what I call the data. Because if we schedule the data according to the heat load and also to how we distribute energy in the data center, or when we can buy the energy, then we really have the full synergy of running a data center from the infrastructure, but also to how we are looking into the energy part to the grid from this part. Meaning that we look at this from a perspective, then it is an overall AI running for this data center part. And we have the cooling and the distribution parts for it. So again, I would look into how we are combining different cooling solutions together with the district or the heating we are getting out from the data center part. Then we look at this ending formula for the energy and how we can make the matrix for the data center. This is where we of course have the overall parameters like CO, carbon dioxide usage effectiveness, power usage effectiveness. But still, we also need to have this XUE because this is the combination of all of them where each factor is weighted to have this pure statement for how the data center is running, leading to our overall look at it, because we look into waste heat recovery, but also material recovery. We have a saying called the 4 R's. Do you know what that is? When we talk about circular economy. It is a reuse, and it's reduce, recovery, and recycle. And this is what we need to look into when we have this. We need to look into data centers from a holistic view. This is not only the energy we are using, this is all the footprint from the CO2 in a data center. Both how we are reusing energy, also how we use the energy we have there, and finally also how is the recycling process for a whole data center. I have this as one of the last one. It is Huawei have a sustainability report we are making each year. And then we have also focus on scope 1 and 2 and 3. It's also called the 3 B's. Do you know what it stands for? I know it, so I can tell you. It stands for burn, buy, and beyond. At this moment, we are almost only focusing on scope 1 and 2. And when we say a data center is CO2 neutral, it's from scope 1 and 2 perspective. We are not considering scope 3. And this is one of the problems when we are talking about CO2 footprint, or as someone called it, handprint. We need to have this focus. Scope 3 is some things we need to. Also, when we have equipment in a data center, how much is recycled before we get the equipment? How was the transportation, the logistics behind it? And how recyclable is the equipment afterwards? This is where Huawei have a huge focus, because we think in the modular and scalable solutions for it. So the circularity for equipment is huge, and this is what we want to promote, to also have focus on scope 3. The reporting will come very soon. At this moment, reporting is for scope 1 and 2, and scope 3 is encouraged, but it will come. So with that, I will end with this one. This is an old saying from an unknown American Indian, but I think it makes good sense in this context. Thank you.